Hello, welcome to Studio Pixel. Welcome to the third chapter of rigging in Maya. In the second chapter, we have already discussed about the spine joints, how to create them, rename, and how to adjust their positions and everything. And in this chapter, we're going to concentrate on the arm portion. So, in this character, if we consider from the shoulder joint, we have to make sure that position of the joint is absolutely correct, because on the joint position everything is dependent, because this area of this shoulder will also will base on that particular joint while it's rotating. If we see a real image of of our humerus bone, this humerus bone is actually very thickness. It has a very round of thickness, but it's actually rotate on some particular point or center of mass, you can say, for individual object. Or in this case, this portion is the base pivot point on which our shoulder joint actually rotates. In this case, we have to assume that which portion, or what will be the exact or the right position for to place our joints. Now this comes with a great amount of practice within the characters are different. So if you really want to assume in a very correct way, you have to rig different kind of characters, different weight, different sort of characters, different thickness, and you will definitely come to know that where you have to put your joint, or you have to place your joints. So I just go to the joint tool. I'll just reset that, and I'll change the length, bone length. And what we will do, I will not draw my joint according to the character. First of all, what we'll do, I'll just it's in perspective view, sorry. Just move on to the front view and joint tool. Fine. So let's suppose I'll just concentrate over this area, because that's where my joint should be. This one is a clavicle bone, I can see from the modeling. So this can be my shoulder point on which I have to concentrate. And then press shift and click another one. This will be for elbow, and by pressing shift you will actually creating this joint is completely straight. Now that is very important. Why? I'm just telling you in future. So after this, we have to adjust this particular joint, or repositioning this according to my character. So I'll just put it over around here. Fine. Now when you are rotating this, remember that you should rotate on the z-axis only on the base joints from the shoulder one, like this. That's it. Fine. Now remember, you cannot rotate this joint like this, and this elbow joint like this. You have to maintain this line. Why so? This is important because otherwise if you create any kind of orientation or rotation around here, and you break this line, you can have some problem while you are creating some putting an IK solver into it. So that's where you have to be very cautious about this. Just press the R for scale and just scale it according to your requirement. Now, but my hands are bent off, so I have to rotate elbow joint and on the y-axis. Now y-axis is pretty cool to rotate, because that doesn't hamper our orientation of the joints. Just switch on the wireframe also, so that I can understand the position of the wrist joint. That's it. Fine, it's almost there. I mean, just a little bit. Oops. Cool. Fine. So that's where your character is it is hand joint, the arm joints are placed. Now the next important thing is the naming, as I said earlier also, and this is very, very important over here. You have to concentrate on this in a very extra way. So I'll just SHLD for shoulder, underscore L for left side, as I'm creating on for the left side of the character, underscore FK, because this will be my forward kinematics joints. So this will actually, you know, concentrate kind of for the FK calculation. So I'll just named it in FK. Fine. Now this one is elbow, ELB underscore L underscore FK, and this one will be WRST for wrist underscore L underscore FK. So now why I create this kind of naming convention, I will definitely show you in the later portion of this chapter. So this is my arm joint that has been created, and now I will just create my clavicle over here. So go to the skeleton. I have already created adjusted the reset the tool earlier, so it will be done. So this will be my position for clavicle, because this is where your character will be, you know, based over this shoulder portion. These vertices over this area will be based on this like a compass. I mean, the pinpoint, the point on which the vertex will rotate will be this. So that's why we have to place the joints. Now this is very important. So make sure this position is absolutely fine. Just back it a bit. Cool. So, and rename the joint clavicle underscore L underscore FK. Now why I'm putting FK, there's no way to put it IK, because clavicle is always been a FK control, but sometimes people love to use the IK controls to make sure that positioning, and they used to work with the position controllers, and that's why they put IK also in the clavicle portion. But it's absolutely up to you whether you are going to use it for FK or IK. So I'm just leaving it to FK. Fine. Switch off that wireframe. Now select this. Now I have to join this, connect these bones. So select this shoulder joint. Shift select the clavicle and press P. That will be the parent of the particular joint. So select the clavicle, shift select the spine joint over here, and hit P. Now you can see my connection has been made. Fine. Cool. So as my connection has been made, I have created a lot of rotation and everything. So just make sure everything is freezed out. So select the clavicle, modify, freeze transformation. This is very important. Edit, reset settings, freeze transformation. So in that way you can see, just wait, just to even before of connecting with this clavicle joint, you should freeze this out, because that is very important, freezing of the values over here. Now you can see that there's lots of values that have been out there because I have already changed a lot of things. So modify, freeze transformation, freeze. You can see that the translate values are not zeroed out. Why this is? Because that is the reason you actually, this joint is actually already a child joint of the world. So if I make it 0, it will get back to the origin or 0 0 0 position. So I don't want that. I want it to be here. So these things doesn't need to be zeroed out, because translate values are lesser important in case of arms, and I don't need to freeze them. And there are certain ways for freezing or making zeroed out, but not directly. You cannot zero out the positional values of the joint, because that is directly connected with the world axis. Okay, now we can shift select this and parent, also shift connected with the spine. So that is my arm joint, and now what I'll have to do, I have to create the other half also. Now go to skeleton and use mirror joint. The mirror joint, okay, just remove this because I'm going to explain this. Okay, now edit, reset settings. Fine. Now this one is the options of the mirror joint. For the first option is the mirror across. Now mirror across is what will be the mirror plane. That means if I put a mirror over here and I stand in this way, in this part or in this position, my mirroring image will be exactly opposite direction over here. So mirror plane, where you are placing this mirror plane, is important. In my case, my mirror plane is actually this particular spine joint, which means this spine joint is actually alignment with Y and Z axis, not X axis. Here by default you will get XY axis, which will be something like this. This is XY axis. So my mirror will be like this, or this way from that way. You can apply and you can see it will shift over there, but I don't need that. I need this way, I mean opposite side of the arm, and which is the YZ axis, which is over here. So now I can have a YZ axis. There is another option that is called mirror function, on which you are actually going to mirror a behavior mirror or the orientation mirror, that I'm going to explain just for next few couple of minutes. So first I just hit mirror, and you can see immediately you'll get a exactly opposite direction of joints. Now this is very important, that your model should be exactly mirrored. So otherwise this mirror function will not gonna happen pretty correctly. So make sure that your model is absolutely mirrored out on both the axis, of positive and negative side of the axis. Fine. Now if you select this mirror joint, then you can see the clavicle, it names clavicle underscore L underscore FK1. Now I don't want that, because that is absolutely different kind of name. Shoulder underscore L underscore FK1, because it's already named shoulder underscore L underscore FK. So as it mirrored out, I just put it to avoid the conflict A1. I don't need that. For creating the exact kind of naming convention, you just select the clavicle, go to skeleton, the mirror joint. Under the mirror joint, FC replacement names for duplicate joints. Now replacement names, I'll replace underscore L underscore with underscore R underscore. Now why underscore before the R? Why I'm not going to use the L will be replaced by R. Now clavicle had also L, so all the L's will be replaced by the R. that I'm not going to, I mean, that is not my intention. My intention is this middle L, because that actually denotes the left side and that will be denoted as the right side. So that's why I should not, we should not use only L. I just you're going to use the underscore L underscore. So that's how it will recognize the specific names. This portion, these three letters, underscore is also count as a character. So underscore L underscore is will be replaced by underscore R underscore. And as FKs, I'm going to retain the FK, so there'll be no need to be change the FK. So just mirror. Now that's why you can see clavicle RFK, shoulder RFK on the right side, elbow RFK, and also the wrist RFK. So that's how we can easily rotate the mirror joints. Now on the mirror joint option, we have another option left to explain, that is the mirror function, which one I told you that one is the behavior, another one is, you can see, the orientation. What is the difference between these two? Now I have mirrored these rotation as a behavior mirror. Now what is a behavior mirror? If you select both the joints and if you rotate, you can see it's like a bird's wings, or both the arms will actually behave exactly opposite like others. I mean, that's where the behavior mirror actually works. If you rotate this way, this will rotate exactly the opposite way. That's where the behavior mirroring comes to play. But if I rotate, because it's actually mirrored out the behavioral movement. Now if I select the joint chain and I put the orientation and then mirror, now you can see my rotational axis of this is a positive one, and it also be the positive one in the same direction. They will actually mirror the orientation axis. Now orientation axis, we can see, if you select and display, sorry, you have to go to component mode, press F8, and now you can see, if you press F4, now you can see the local axis of that particular joint. Now in this case, you can see y-axis is over this way, z that way, and x towards the child. And if you select this, you can see the y-axis is actually flipped out. Sorry, x-axis is actually in a different direction, because that is where you are actually mirroring the exactly orientation axis. That's why if you select, I'll get back to the come out from the component mode, and if we rotate over in this section, in this in this direction, you will see the negative value will come up. But if you see that way, you will see this a positive value, because we have mirrored out the orientation joints, I mean the orientation of the axis. We are not having the behavioral movement. If you select both the joints and you will rotate, you will see it will not be behaving in exactly the opposite limb. It will exactly rotating in the same way, because I have mirrored out the orientation axis. So orientation axis is maintaining the direction of the rotation. So that's where you you can use this when you are actually moving two limbs in the same direction, like you can say when I'm moving my 2 feet with one single direction, or maybe hands on one single direction. That's where we can use this rotational behavioral mirroring, the orientation mirroring. But in basic way, for the mirroring out, I'll definitely go for the behavioral as my characters is concerned. So make it a behavior mirror function, and then hit mirror. So that's it. That's why I have renamed my left to right, and also I have created the rotational function just to make sure that my everything I have created in the right position. And just set. That's fine. Let's move a bit. Okay, fine. So just delete this part again, select this and freeze transformation, fine. So that's the third chapter, and we'll move on to the next chapter. We'll move on to a different portion. Hope you enjoy this, and please don't forget to like us in Facebook and Twitter, and also get subscribed in the YouTube channel to stay updated or from our side. So hope you enjoy this. Thank